Hi guys, today we'll write a function that takes in an integer n and returns true if n is a prime number and false otherwise. By definition, a prime number is a whole number that is actually greater than 1 and it can only be divided by 1 and itself. So some examples of prime numbers between 1 and 20 are 2, 3, 5, 7, 11, 13, 17 and 19. Notice that these numbers can only be divided by 1 and itself. Do pause this video for a while to give it a go. Alright, before we jump right into the code, let's conceptualize how we can actually solve this. Let's say we want to check if 13 is actually a prime number. So n is equals to 13. For a number to be a prime number, it can only be divided by 1 and itself. So we actually have to check whether 13 can be divided by these numbers 2, 3, 4, 5, 6. The reason why we don't check 7 is because 7 is more than half of 13, which means that 13 will never be divisible by 7. So here, we just need to check 2. So it's not divisible by 2, it's not divisible by 3, it's not divisible by 4, it's not divisible by 5, and if it's not divisible by 6. So at this point, if we do not find any number that 13 is divisible by, we know for sure that 13 is a prime number. So let's use another example. So if n is equals to 15, so we need to check for the following numbers 2, 3, 4, 5, 6, 7. So we don't check for 8 because 8 is more than half of 15. So here, 15 is not divisible by 2, but then 15 is actually divisible by 3. So at this point, we know that 15 is definitely not a prime number. Alright, let's write our function. So define is prime. So it takes in a n. So first things first, let's print out the numbers that we need to check. For I in range, so because we start from 2, and we end at n divided by 2 plus 1. So let's print I. Let's call our function. Let's put 13. So we get 2, 3, 4, 5, 6, and if we put 15, we are going to get 2, 3, 4, 5, 6, 7. Alright, so next step, we need to check whether n is actually divisible by all of these numbers. So I and n modulo I. So n modulo I is going to give us the remainder if n is divided by I. So if n modulo I is equal to 0, means that n is actually divisible by I, which we do not want. Let's print this first. So we have 1, 1, 1, 3, 1. Okay, so if we change this to 15, we are going to get 1, 0, 3, 0, 3, 1. So here, notice that 15 is actually divisible by 3 and 5. So because of that, n modulo I for 3 and 5 is going to give us 0. So with this in mind, we know that if n modulo I is equal to 0, we can return false immediately, because once we meet a 0, we know for sure that n will not be a prime number. So at the end of the for loop, we are going to return true. So why we return true at the end of the for loop is because if we do not meet any number that n is divisible by, it means that we know for sure that n is actually a prime number. So there we have it. So let's test our function. So for I in range 2 to 20, if is prime, I print I, and let's print them on one line. Okay. Alright, and there we have it, 2, 3, 5, 7, and so on. So one more thing that we probably might want to add is this. So if n is 1 or lower, return false, because by definition prime numbers are positive. Yep, and there we have it.